So welcome everybody to our third video on 160 Maths on Circle Theorems, and in this video we'll be going over some quite common exam style questions taken from actual exam papers. Now there will be a copy of the worksheet that I've used in the description below for you to download, and you may want to have a look at this before working through this video, as I'll be going through the answers and the general thinking behind answering each of the questions. So let's get started on some Circle Theorem GCSE exam style questions. Now the key thing to remember is that circle theorems can appear on both the non-calculate and the calculator paper. Also, that none of the diagrams will ever be drawn to scale, so please do not reach out for your protractors to measure certain angles. And obviously please be aware that you will need to learn the actual definitions of all of the circle theorems covered in the previous videos. Let's get started on this first question. So the question says the diagram shows a circle with centre O, which is always labelled as O, the centre is, and it says work out the size of the angle AOC, give your reason for your answer. And this question is worth 2 marks. So first things first, we know that this is, I can see an arrowhead, so that's the theorem I'm going to be using. And what do I know is that the arrowhead, the angle at the circumference is half the size of the angle at the centre. So what I need to do for this one is just simply do 85 times 2, which is going to give me an answer of 170 degrees. Now in terms of the reason, this is where I need to give the actual definition. So the definition is that the angle subtended at the centre is twice the size as the angle subtended on the circumference. So something along those lines would be absolutely fine for the 2 marks. So looking at B, it says P, Q, R, S are points on the circumference of the circle. Work out the angle of PSR, which is what's highlighted here. Now in terms of this, what I need to use is the theorem involving the quad, and the theorem of the quad basically says that opposite angles always add up to 180. So to work out what this angle here is, all I need to do is 180 minus 126, which is going to give me 54 degrees. And again, all I then need to do is just write down the definition. So opposite angles in a cyclic quadrilateral, if I can spell it right, add up to 180 degrees. You could also go that opposite angles add up supplementary, but again that's probably the most common. Then says for question C, says W, Y, X and Z are points on the circumference of the circle centre O. ZX is the diameter. Angle YZX equals 63. Work out the angle of ZWY. You must show you're working out, and you may include, now a lot of diagrams now, these circle theorem questions are allowing you to show you're working out on the diagram, which is a massive help. It just means that you don't have to have the correct notation in terms of writing that down. Obviously if you want to, that's absolutely fine, but working it out is going to be there as it is. So if ZX is the diameter, then this angle here is going to be 90 degrees. Now obviously what I'm wanting to work out is what this angle here is, and you can see, what I can see is I've got a bow going on like so. So to work out what this angle is, what I'm going to do is use the fact that I can see a right angle or a triangle, and I know what 2 of the angles are. So to work out what this angle here is going to be, all I then need to do is do 180 minus 90 minus 63, in which we get an answer of 27 degrees. Now moving on to our second question, it says PQRS are points on a triangle. PXR and QXS are straight lines. PX equals SX. Prove that QS is not the diameter of a circle. So for this, as you can see, what we need to work out is, let's have a look at what the angle is. So QS, we need to show that this line here is not the diameter. Now how do we do that? Well, if that is the diameter, so if QS is the diameter, then the angle of QPS has got to equal 90 degrees. So this is the proof that I'm going to be using. So what I need to do is I need to work out what this angle here is going to be. So let's have a look at how we work this out. Well, for starters, I can see a bow. Just highlight where I got that bow, which means then if this angle S is 27, then this angle here is going to be 27. So the next thing I then need to do is work out what that length there is. Now in the question it says that PX, which is this here, is the same as that length there. So this therefore means that this triangle here, which if I just try and use a yellow highlighter, so this triangle here is an isosceles triangle. Now if that is an isosceles triangle and this angle here is 50, then these two angles here are going to be 180 minus 50, which equals 130, and divide that by 2 and I get an answer of 65 degrees. So this angle here is going to be 65 degrees. Now from that, what I can then do is we'll add up the two angles. So here the angle of QPS is equal to 27 plus 65, which gives me an answer of 92 degrees. So therefore QS, so as, let's put as QPS is not 90 degrees, then QS is not the diameter circle. So something along those lines would be absolutely fine for the 4 marks. So moving on to our next question, it says that A, B, C, D are a cyclic quadrilateral, and what we need to do is work out the values of x and y. Now for this, what we know from using the theorem is that opposite angles add up to 180 degrees. So if I look at those two blue angles, I know that x plus y plus 70 equals 180 degrees. And I also know that this angle B and this angle at D also adds up to 180. So x plus 2y rather plus 40 equals 180. Now because we've got two variables, this is basically going to turn into a simultaneous equation question. So what we need to do is take the numbers over to the side. So then what I end up with is x plus y equals 110, and I've got x plus 2y equals 140. So now I just go through the whole simultaneous equation process. So here my x's are the same quantity and the same sign, so I subtract the two. So what I end up with is minus y equals minus 30. So y equals 30 degrees. So there's one of my angles. And then if I then use this rule here, let's just put it over here. So I've got x plus y equals 110. Well, if y equals 30, I've got x equals, then take the 30 over to the other side and I get x equals 80. So hopefully there's a bit of space underneath for me to write down my two angles. So here x equals 80 and y equals 30 degrees. Moving on to question 4a. So again, very similar. You can see we've got a arrow and I can see a triangle there as well. So it says E, F and G are points on a circle with centre O. Work out the size of angle W. So we know that straight away that this angle here is going to be 100. Now we know that although it's not marked, that these two lengths here are going to be the same. Why? Because they're both the radiuses of the circle. So it's definitely going to be that triangle of Q, E, O and G is going to be an isosceles triangle. So to work out W, it's going to be 180 minus 100 divided by 2, which gives me 80. Half of that is 40. Then moving on to B, it says A, B, C and D are points on the circumference of the circle, and the question is asking us to work out the size of angle X. Now we know that on a cyclic quadrilateral, these two angles here add up to 180. So X plus 68 equals 180, meaning that X equals 112 degrees. So here we've got 112, and our reason, well, let's just make sure that degree doesn't look like 1,000. So let's go. Cool. There we go. And reason for it as opposite angles in a quadrilateral add up to 180 degrees. Then moving on to question C. So it says PTQ is a tangent to the circle. R, S and T are points on the circle. And the question is asking me to write down the size of angle Y. So for this, what we need to do is use the alternate segment theorem. So if this angle here is there, then basically that's going to equal 37. So it's 37. And then the reason for this is I can actually quote just the alternate segment theorem for the 2 marks. Then looking at question 5, so it says A, B, C, D, E and F are points on a circle, and it says circle the line that is the diameter of the circle. Now obviously if a line is the diameter, then the opposite angle to that needs to be 90 degrees. So it's definitely not going to be A to C, because the side that's opposite A to C is this angle here. It's not going to be, so working out what this angle here is going to be, so F, well that's going to be 100 if you add the 2 angles up, so that's going to add up to 80. So this side B to E is not the centre. So now let's have a look at the other angles. So again, working out in terms of those, let's have a look. So we've got this angle here, so that is going to equal 90. So that therefore means that A to D is the diameter of the circle. Then moving on to question 6, it says A, B, C are points of the circle. BC bisects the angle ABQ and PBQ is a tangent to the circle. It says that angle CBQ equals X, and we need to prove that A to C is equal to B to C. So we just need to show that this is a isosceles triangle with those 2 sides being the same. So how do we do that? Well, okay, let's have a look. We've got no numbers to work with. So using the alternate segment theorem, if this angle here of CBQ is X, then this angle here is also going to be X. Now in terms of working out, as this is well, because we've been told that BC bisects the angle, that means that this angle here would also be X. So therefore then, if we've got 2 angles the same in a triangle, it's destined to be a isosceles triangle, and that's what we've done. So what we need to now do is actually write down the definitions for this properly. So let's start by doing this. So we know that A angle BAC is equal to X or equal to CBQ. And the reason for that, which is always you need to write, is the alternate segment theorem. Then, in terms of this, we know that as, and then just quoting that, so as BC bisects the angle ABQ, then angle ABC equals X, as it's half of the angle ABQ. So as we have 2 similar triangles, or similar angles I should say, 2 similar angles, the triangle of ABC is isosceles. So therefore A to C rather equals B to C, and there we've proved it. So something along those lines would have been absolutely fine. So moving on to question 7, which looks a bit of a mess. It says A, B, C, D are points on a circle with centre O. AC is a diameter to the circle and AT is a tangent to the circle. And the question is asking us to work out the size of angle X and Y, and it's worth 4 marks, so this is going to be a lot. Now, so to get started on this question, let's first make sense of the information that's been given. So we know that A to C is a diameter to the circle, so that means that this angle here is going to be 90 degrees. Now we also know that A to T is the tangent to the circle, which kind of involves several things in terms of rules. So we know that this angle here is going to be 90, as well as this angle here is also going to be 90, because the radius meets the tangent at 90 degrees. Now, in terms of looking at the alternate segment theorem, I can also see that angle Y is going to be what this angle here is. And in terms of this angle here, that's going to be 30 degrees, as this is going to be the same as that angle there. Let me just colour that in. So that's what this angle, those angles there are going to be equal. So then to work out what x is going to equal 90 degrees minus 30. So x equals 60 degrees. So that's one of my angles done and dusted. Then to work out what y is, well, we can see that with this triangle here, this is going to be an isosceles triangle because I've got two lengths that are the radius of the circle. So if I just take that triangle out, and this angle here is 72 degrees, and to work out what these two angles here are going to be, all I need to do is 180 minus 72, which is 108, and then divide that by 2, which gives me 54. So this angle here is 54 degrees. So what I've then worked out is that this angle here is 54. Now from this, if I look at this in all of its entirety, I know that y plus 54 equals 90. So therefore y is going to equal 36 degrees. And there I've got my two angles there. We can write y equals 36 and x equals 60. So looking at question 8, it says that ABC are points on a circle, and it says CD is a tangent. And what the question is saying is, for part A, is assume that the triangle ABC is isosceles with AC equals BC. I want to prove that A to B is parallel to D to C. Now there are several ways in which you can do this, but I'm just going to go for one common way rather than make this video last longer than it needs to be. So what we're going to do is let's have a look at some of the angles. So we know that D to C is a tangent. So this here is our tangent. Now we don't know the radius, so I'm guessing that as we've got a tangent, we're looking at alternate segment theorem. So here we know that this angle here is going to be equal to this angle here. And likewise, if I wanted to, that this angle here is going to be the same as that angle there. Now in terms of, so let's just start by writing that down. So angle DCB is going to be equal to ABC, and why? Because of the alternate segment theorem. Now, so if I just label this x, this is going to be x. Now our next statement says that we can assume that A to C is equal to B to C, which basically means that this length here is the same as that length there, which therefore then goes on to show that this angle here is going to be the same as this angle here because it's an isosceles triangle. So let's start by writing that down. So CAB is equal to ABC, as they are, because it's an isosceles triangle, as A to C equals B to C. Now, as we can see, now if the two lines are parallel, so if DC is parallel to AB, then angle DCA should be equal to angle BAC. And the reason for that is because they are alternate. And as you can see from the diagram, that this angle here is the same as this angle here because they're both x, which they are. Just write both x, and then so therefore AB is parallel to DC. So moving on to question B, it says in fact the triangle ABC is equilateral. Tick the two boxes in the statement that must be true. Well, if that's going to be true, then AB is going to be parallel to DC, and that AC is going to bisect the angles of BCD, and so it's just the top two that we then need to tick. Looking at question 9, so it says ABCDE are points on a circle, BFD and AFC are straight lines. D to C is equal to DF. Work out the size of angle X. You must show you're working out, which may be on the diagram, which is helpful. So looking at this, I can see quite a few things cracking off. So let's have a look at notifying what some of the statements are. So we know that this here is an isosceles triangle. So DFC is an isosceles triangle. Now I can see quite a few, I can see a bow. So this angle here is going to be 24 degrees. Now it's not asked for actual definitions of the stating reasons, it's just asked for working out. But I'm just going to write down a bow just so that they can see what this therefore is going to be. Now if that's going to be 24, then to work out what this angle here is, and let's just use a bit of colour, this angle here is going to be the same as this angle here. So then that then is going to be 180 minus 24, which gives me 156. Then if I divide that by 2, what do I get? Well, I'm going to get an answer of 78 degrees. So this angle here is 78, which means that this angle here is going to be 78 as well. Now, one thing I do notice is that this is a straight line. So these angles here collectively must add up to 180. So here I've got x plus 2x plus 78 equals 180 degrees. So I take the 78 over to the side, in which I've got 3x equals 102. And then if I just divide 102 by 3, I get an answer of x equals 34 degrees. So looking at question 10, it says here is a cyclic quadrilateral. And it says that x to y is in the ratio of 5 to 7, and we need to work out the angle of w. So the first thing we should know is that these two angles here add up to 180. So x plus y equals 180. Now if I look at the ratio, which is going to be 5 plus 7, which is 12 parts. So we do 180. I don't know why I've wrote 1800 there, so let's get rid of that 0. So here we've got 180 divided by 12 equals 15. Now x represents 5 parts, so x equals 5 parts. So then x equals 5 times 15, which is 75. Now from this, if x equals 75, we also know that these two angles here must also add up to 180. So here I've got x plus 20 plus w equals 180. So here I've got x plus w equals 160. Now if I know that x equals 75, I've got 75 plus w equals 160. Take the 75 over to the other side, in which I get w equals 160 minus 75, which gives me an answer of 85 degrees. And then moving on to our final question. It says that A, B, C are points of a circle, DCB is a straight line, PAQ is a tangent to the circle. Sam is trying to work out the size of angle M, and here is his working out. Make one criticism of his working. So let's have a look at what he says. So it says angle ACB, which is this angle here, is equal to 56 as angles in the same segment are equal. Well, that's his first mistake. Is he's actually not used the correct definition, and that's what will be the answer for this. So not used the correct sort of proof or theorem in the first line, as Sam should have quoted the alternate segment theorem instead.